Rate law is defined by mathematically rate is equal to rate constant, which is K. And say if the reactant was A and if there was another reactant B with its appropriate exponent of M and N, and those are the reaction order. We will encounter several problems, calculation problems, where we'll need to find out that M and the N order and also the rate constant to bring about a specific rate law for a specific reaction. We covered in the first video of method 1, and here we're going to target method 2. For method 2, it requires a little bit of algebra and also to put ratios between two different rates and also two different ratios of reactant concentrations. Let's take for example. For example, if you look in this table, you'll see a various amount of trials of constant, and you see a different concentration of NO and chlorine. The reaction is nitric oxide with chlorine gas forming into 2NOCl. Now, when we're producing to 2NOCl, we're only looking at the reactant to determine the rate law. So the rate law here would say rate is equal to the K, which is the rate constant, concentration of NO to the M power and chlorine to the N power. And we're going to try to figure out the M and also the constant K. So here is the question. It says using the initial rate method and the experimental data, determine the rate law and the value of the rate constant for this reaction. And we will go ahead and compare two different rates and making sure one of the reactant concentration stays constant. For example, if you look at trial 1 and trial 2, you'll notice that the concentration of the nitric oxide is the same, whereas for the chlorine, it does differ. It doesn't differ by a factor of 2 or 3, but it's somewhere between factor of 1 and 2. So it's somewhere in between. So the calculation becomes quite challenging if you were to try to use method 1. In method 2, what you're going to do is you're going to compare trial 2 and trial 1 by putting the rate 2 on top and rate 1 on the bottom. Then you have your constant and you write rest of the concentration, M power Cl to the N power and NO to the M power and Cl2 to the N power. Now for the top, it's for trial 2, right? These are for trial 2, whereas the bottom one is for trial 1. So if you look at trial 1 and 2, you'll notice that the concentration of nitric oxide are the same. So you can easily cancel these out. The K will also be the same because we're referring to the same exact reaction. So the rate of the 2 divided by the rate of the 1 is equal to the concentration of the chlorines in trial 2 and trial 1. So let's put in some values in. So rate of the 2 would be 0.00450 divided by 0.00300, which is equal to chlorine concentration at trial 2, 0.15 to the N power. We don't know what that N power is, not yet. That's what we're trying to solve for, and 0.10 for the trial 1. We'll go ahead and calculate this left side out by using our calculator here. And let's go ahead and do the right as well. So that would be 0.0045 divided by 0.00300 and enter. That gives me 1.5. So there's 1.5 on the left side. And then let's go, what about the right side? The right side, you're going to take the 0.15 divided by 0.10. What about the exponent? You can make this like a derivative as if the exponent is outside because the exponents are exactly the same. 0.15 divided by 0.10. That's 1.5 again. So on the left side, we have 1.5 here, and this would be 1.5 to the n power. So if the n power are exactly the same, we can just divide the top, the numerator, and the denominator. Well, what must n be in order for them to equal out? The n must be 1 in order for the left and the right to equal out as 1.5. So we know the reaction order for chlorine must be 1. What about for the nitrogen? So we're going to now keep the chlorine constant, right? And you'll notice that trial 1 and trial 3 has a chlorine constant, whereas the nitric oxide now is different. So let's go ahead and set that up. To set that up, you are going to have rate of 3 for trial 3, and the rate of trial 1 is equal to the K concentration of nitric oxide and concentration of chlorine all over K of NO to the M power and Cl2 to the N power. Now we said the chlorine concentration is equal, so we're going to cancel those out. K, we already know, so let's plug in the values for rate 3 and rate 1. Value for rate 3 is 0.00675. Divided by rate 1 would be 0.00300 equals to the concentration of nitric oxide to the M power, and at trial, I apologize, this is for trial 3 and trial 1, so this should be at trial 3, so that should be 0.15, and that bottom should be 0.10 to the M power. So if you calculate this out, you will find that this on the left-hand side will be 2.25, okay? Whereas on the right-hand side, it will be 1.5 to the M power. You might wonder, well, how do I get M? And the other one, you'll notice that N was really easy to get because they equal to each other to 1. Well, how do we get M? Well, in order for that M to sort of disappear or not to have the exponent, you're going to ln both sides. There's a function in the calculator called ln. You will have to ln both sides. That makes the M to come in front of the ln as a coefficient. So if I were to write this, ln 2.25 is equal to m ln 1.5. So we'll go ahead and punch this into the calculator. On the left-hand side, ln, let's go ahead and divide ln 1.5 both sides. ln 1.5 divided by ln 1.5, so ln disappears and you just have m is equal to all of this. All right, so let's go ahead and calculate that. So there is an ln function right here, okay? So that's ln of 2.25 close to parentheses divided by ln 1.5 and close the parentheses. And then hit enter and you get m is equal to 2. So m is equal to 2. So the reaction order is for this one, for nitric oxide is 2. Let's write the rate law on top here. Since we're running out of room, we'll go ahead and rate law on top. So rate law over here, you can say rate is equal to the K, which we don't know the value yet, but we do know that it is for nitric oxide, the reaction order is 2. And for chlorine, it is 1. So that's my rate law. But it's also asking for the rate constant. So we're going to have to find the rate constant. In order to find the rate constant, you will do the following. So I have cleared out some space so we can go ahead and calculate things out. Well, you already have rate over here. One of these rate will do in this table, any of them. Pick any of them. We know the reaction order. We also know the concentration. So we only need to solve for K. So rate, then we can divide both sides by the concentration of the reactants, both sides. And you can cancel these out, and your rate with K, or rate constant, is equal to any one of these rate with its corresponding concentration, not just any one of them concentration. So I'm just going to randomly pick one. Trial 1 looks like a pretty simple calculation right here. So I'll just try picking this one. So rate is 0.00300 divided by concentration is 0.10 for nitric oxide and to the second power, and for chlorine is 0.10 to the first power, and that will give you the rate constant. So let's go ahead and punch that into our calculator. In our calculator, we'll go ahead and punch it in 0.00300 divided by the 0.1 to the second power, right? And then we're going to go ahead and the bottom part is also to the first power, which is just 0.1. We're going to double parenthesize this so that we know the whole thing goes on the bottom. Okay, I double parenthesized it and then hit enter. So we know the constant is 3.0. Now, what is the unit? Well, unit for a third order reaction is 1 to the m second power and seconds. Or you could have written this as 3.0 m to the negative second power and negative first power of s, or seconds. Let's do a learning check based on what we have learned so far. Please pause this video and check the key. Here is the key.